Hello there, welcome to this video. In today's video we will discuss what actually ChatGPT is and how it works. Before that, do you know? The GPT, Generative Pre-trained Transformer, is a deep learning model developed by OpenAI that has been trained on a large corpus of text data. The GPT-3 model is the latest version of the GPT series, with over 175 billion parameters, making it one of the largest language models to date. The GPT-3 model can perform various tasks, including language translation, question answering, and text generation. Feel free to like and share this video in your network, and help others to learn and grow. So, have a look, what we will be taking away from this videos. Firstly, we will look into introduction with ChatGPT. Secondly, we will deep into what is natural language processing, NLP. Then step down with steps of NLP. Fourthly, transformers. And lastly we will sum up with example of natural language processing. So without further ado, let me deep you to today's video. ChatGPT reached a record-shattering 1 million users in its first 5 days of existence and is without a doubt the most talked about topic in tech right now. You will learn how it works, and this will provide you many benefits such as helping you to use the model more effectively, evaluate its outputs more critically, and staying informed about the latest developments in the field so that you're better prepared to take advantage of new opportunities. ChatGPT is a type of natural language processing model known as a generative pre-trained transformer. Developed by OpenAI, these are the two big terms we will focus on in this video. On top of that, you will also get a base understanding of common machine learning techniques like supervised learning and reinforcement learning, which were used to make ChatGPT as good as it is. While doing the research for this video, I actually met an old friend of mine, or should I say 4 of mine. Proximal policy optimization, the reinforcement learning algorithm which was also developed by OpenAI, was used to train ChatGPT. I wrote my computer science thesis about this thing. But don't worry, we won't talk about math at all in this video. Instead we will talk more about language. Natural language processing is the cross-section of linguistics and computer science, and you're already confronted with NLP all the time. Autocorrect is NLP, or to suggest this, NLP and things like automatic plagiarism checks also make use of natural language processing. But what exactly is natural language processing? It's a subfield of artificial intelligence that focuses on enabling computers to understand, interpret, and generate human language. This is at the core of ChatGPT. It needs to be able to understand what you are saying and then generate a human-like response. Let's start with the understanding part. Computers don't know English or German or Spanish or any other language besides numbers and vectors. So how do we get it to understand what we are saying in the first place? Here is an example of, or 7 steps of natural language processing might be applied to the sentence. I am learning about ChatGPT right now. First is segmentation. Here we split the sentence into smaller units or segments that can be processed by the NLP model. We can split it into individual words or tokens. The term token pops up a lot here. Even OpenAI's pricing model is based on set tokens. Prices are per 1,000 tokens. You can think of tokens as pieces of words where 1 tokens is about 750 words. This paragraph is 35 tokens. Next up, tokenization, converting the words to a standard format, for example lowercase. The next step is to remove common words which don't really contribute anything to the meaning of the sentence, such as about and right. This can help to reduce the amount of data that needs to be processed by the end of the model and improve its performance. So in this case we are left with, I am learning ChatGPT now, which still has the same meaning as a sentence. We can also reduce the words to their base form or stem, in order to improve the model's ability to generalize and recognize patterns. This might involve using algorithms that remove suffixes from the words, leaving only the core meaning for this sentence. The stemming step might reduce the token learning to the stem learn, and we can even go further here with lemmatization, which is quite similar to stemming. It reduces the words to their dictionary form M turns to B. Our sentence is now reduced to IB learn ChatGPT. Not really grammatically correct, but you get what it means. In speech tagging, we assign a tag to each token indicating its role in the sentence. For example, noun, verb, adjective, etc. This can help the NLP model to understand the syntactic structure of the sentence. And lastly, named entity recognition. In this final step, we identify and classify any named entities in the sentence, such as proper nouns that refer to specific people, organizations or locations. Once all the steps of the NLP process have been applied to the sentence, the model will have a more complete and accurate understanding of its meaning and content. By running through steps 1 to 7 for a vast amount of data, the computer is looking for patterns and structures that can help it understand the meaning of the words and sentences. In other words, it starts learning how exactly it learns. You will see in a bit this understanding is typically represented using numerical or vector-based data structures that can be easily processed by the model. Here is what it could look like. The speech tagging as an example, the better it understands, the better it can use this knowledge to generate its own text that is similar to human language. This perfectly leads us into how GPT generative pre-trained transformers work. Generative means the model can generate something, in this case a human-like language or a human-like text. Pre-trained refers to the fact that the model has been trained initially on the vast amount of data we just discussed. Keep in mind that for this specific model, it also means that doesn't get any better the longer you chat with it. It has been pre-trained. What you get is based on a snapshot of the internet with the data cutoff in September 2021. And the last part of the term are transformers. These transformers are the crazy part which made this whole technological breakthrough happen in the first place. That for us was like, okay, this is going to work. You know, the transformer came out late 2017 and my co-founder Ilya immediately was like, that's the thing. That's what we've been waiting for. So you take this sort of very early nascent. They'll put in a transformer and then that's GPT-1. They consist of an encoder and a decoder. These 7 steps we just described are all happening in the encoder. So the output of the encoder is a numerical or a vector-based representation of the input sentence that captures the meaning and structure of the sentence in a compact and efficient form. This is what we work with in the decoder. The goal here is dependent on the specific use case of the transformer, but for us it's sequence-to-sequence transformation. Feeding in one sequence like a sentence or a question and then getting back another sequence like another sentence or an answer to our question. For example, if we take our input sentence, the decoder might generate an output sequence like. As a result, I now have a better understanding of how ChatGPT works and what it can do, which is similar to human language and captures the meaning and structure of the input. These transformers are a fairly new machine learning technology. They were introduced in 2017 in the paper with the fantastic title "Attention is all you need." Transformers use a self-attention mechanism which allows the model to focus on the most relevant parts of the input when generating its output. It does so by calculating how much attention each vector should receive based on the other vectors in the input. That's why they are so good at summarizing content, because it understands context, since the vector's attentions are based on the other vectors of the sequence. This breakthrough was essential for technologies like ChatGPT, because it allows the model to effectively process input sequences of any length in a parallel and efficient manner. It vastly outperforms recurrent neural networks and convolutional neural networks in this task, which are simply too slow for our use case. But we need to make a step back here because we are already talking about the outputs of the model. But how was it trained in the first place? Or may I got creative here using a variety of different machine learning techniques to get the best results. An initial model was trained through supervised fine-tuning. Here a lot of prompts were created and the human described the desired input. The language model is basically looking at that to understand what's going on. It's like your math teacher explaining something on the blackboard while you sit there watching him and trying to figure out what's going on and how it works. Oh, may I also trained a reward model with a similar process. A prompt delivers 4 different answers and the labeler ranks the output from best to worst. This data is then fed to the model. And finally, it's about optimizing a policy against reward using reinforcement learning. This is the fun part because here the model tries to teach itself how to get better. Say you have a dog. You want the dog to sit on command, so you start by showing the dog a treat and saying the command sit. When the dog sits, you give it the treat as a reward for performing the desired action. Over time, the dog learns to associate the command sit with the action of sitting and the reward of getting a treat. Humans also naturally learn skills. That way you don't learn how to ride a bike. By looking at someone ride a bike all day, you learn riding a bike by getting on a bike, falling on your face a few times and figuring out how it works. What went wrong? How can I do this better until it feels natural? Falling on your face is the punishment for a bad action. Dopamine from learning the skill and being able to move faster is the reward for a good action, and this is how machines can learn through reinforcement learning as well. I will give you a concrete example from my thesis. I built a super simple game in Unity in which the AI is controlling the green character. It can move and shoot. Enemies are spawning from the sides of the map and following the character. Now the reward model could be shoot an enemy +1, collide with an enemy -1, you lose, take a shot -0.001 to simulate ammunition which is not infinite. The AI then starts playing the game and tries to maximize this reward. Through a lot of trial and error it learns, it adapts its own policy, which is its own rule set of when to perform which action with the information it has, and the performance gets way better over time. And this is exactly what happened in the training of the ChatGPT model as well. I believe that it will usher in a new paradigm of AI power tools that will do incredibly impressive things over the next few years. I also believe that we are on the verge of a second renaissance in technology, business, and art, even without taking AI into consideration. Hope you find this video valuable. Feel free to like, share and subscribe this channel. Your single like on this video keeps us motivated to bring more valuable content like this. Thank you for your support. See you in the next video. Till then, keep learning, keep growing.